This video summarizes stoichiometry, focusing on applying the mole concept to chemical reactions. Stoichiometry is the study of calculating the quantities of reactants and products in a balanced chemical reaction. The term comes from the Greek word stoichio, meaning element, and metry, meaning measurement. Stoichiometry involves three main types of conversions: mole to mass, and mass to mass conversions. This chart illustrates how to navigate between mass, moles, and particles of substances A and B using molar mass, Avogadro's number, and the mole-to-mole ratio. The ratio 4:5, 6:4 from the balanced equation can mean either in terms of molecules or in terms of moles. For example, 4 molecules or 4 moles of NH3 react with 5 molecules or 5 moles of O2. Let's solve a stoichiometry problem, ammonia synthesis. First, balance the equation and then set up the mole ratio. The final answer is 31.50 moles of NH3. Here is a stoichiometry problem for a chromium reaction. We start with an unbalanced equation, then balance it, set up the mole ratio, and find the final answer of 11.25 moles of H2. This mole-to-mole calculation determines the amount of H2O produced from O2. Remember that a correctly balanced equation is essential to obtain the right answer. In this problem, we calculate the moles of NO produced using a mole ratio based on the moles of H2O produced. The calculation yields 10 moles of NO. Now we will focus on mole-to-mass conversions and mass-to-mass conversions. For this mole-to-mass conversion, we calculate the grams of H2O produced from NH3. We use the mole ratio and the molar mass of H2O to get 59 grams. This is a mass calculation from a mole amount. We find the grams of O2 required to produce 0.3 moles of H2O, resulting in 8 grams of O2. Next, a mass-to-mass conversion. We calculate the grams of NO produced from 12 grams of O2. This involves 3 conversion factors, yielding 9 grams of NO. To find the grams of sodium chloride produced from 20.00 moles of NaClO3, we follow the steps for conversion, identifying known values, conversion factors, and the value to find. Finally, we calculate the moles of O2 produced when 40 grams of sodium chloride are formed. We set up the mass to mole conversion to get 1.03 moles of O2.